Let's start with the demo. This is our first Chainlink automation for bundle executor.sol contract, which basically checks for any active plan stored on plan stored.sol contract. Upon getting an active plan, it perform upkeeps to execute two operation, one swapping of the token and another the CCIP transfer of the token. So as you can see, the last time it ran on 7:36. Let me quickly go through the UTC time. It's right now 7:44 and our automation last ran on 7:36. Now let's quickly move on to the next automation. This is the time-based automation for our function consumer.sol. As you can see, it ran previously on 7:35. So let me quickly unpause it. This automation actually performs in every 5 minutes. It calls a Chainlink function for getting the arbitrage plan and stores it to the plan stored.sol contract. As you can see, the next scheduled runtime is 7:45 and the current time is 7:45. So we will soon get the latest run. Let me refresh it. As you can see, it ran on 7:46. So let me quickly go to the Chainlink function tab. Yeah, as you can see, we have a pending transaction. The fulfillment request is here. Let me refresh it and give it some time to reload. Yeah, we have a completion. Let me decode it. We have a decision that execute the trade with one with amount and some gas fee and other parameters. Let me go to the our previously seen automation and it should have run by now. Yeah, as you can see, it has run on 7:47, which is the current time right now. So it probably should have initiated a CCIP transfer. So we can see the transaction has. Let me go to the Explorer. As you can see, the token is transferred to the zero address, the CCIP BNM token. So the token is being burned from our Ethereum Sepolia chain. Now let's go back to the CCIP Explorer, refresh it, and we can see our new transaction pop in. Yeah, it's 1 minute ago. We have a new transaction. This is in the pending state. And we can, after some time, see that it is being passed. Our product architecture, we have three components. First one, the source chain is Ethereum Sepolia. The destination chain is being Arbitrum Sepolia and an off-chain layer, which includes the Chainlink automation, Chainlink function, and other APIs. We have deployed two Uniswap V2 contract in both of our source and the destination chain. We have created a WETH and CCIP PNM pool, and we intentionally created a 25% price difference so that we can find a arbitrage opportunity in the pools. Let's start with the contracts. First, we have function consumer.sol contract, which is being triggered in every 5 minutes by Chainlink automation. In every trigger, it calls a Chainlink function. And Chainlink function has its logic to first fetch the market data, such as the price of the token pair from both of the pools and the gas fee in both of the chain, and passes all the data to Amazon Bedrock API. So Amazon Bedrock API analyzes all the data and returns a final decision whether or not we should execute the trade. The decision is being stored in the arbitrage function consumer.sol, which parallelly stores the decision to the plan stored.sol contract. So plan stored.sol contract used here to store all the plans, and every plan expires in 5 minutes. Next, bundle executor.sol contract, which is also automated by Chainlink automation. So it in every block or 15 or 30-second intervals calls check upkeep function, which monitors a plan store.sol contract. It checks if is there any active plan stored in it. If it gets an active plan, it fetches it, it validates all the parameters, and then it sees if the arbitrage is feasible or not. If it's feasible, then it calls perform upkeep function, which does two things. First, it swaps our WETH to CCIP BNM token and then sends the token to our destination chain in our Arbitrum Sepolia network through our CCIP protocol. Next, we have a last contract, remote executor.sol contract, which is a CCIP receiver contract, which is receiving a bridge token. So it's getting a CCIP BNM token and swapping to the WETH. And after swapping to the WETH, we're getting our final token with the profit. So we are transferring to our any of our treasury account. So this is the total flow of the protocol. In the mainnet scenario, in case of deploying our own Uniswap V2 mock contract, we can use multiple dexes in multiple chain, and we can monitor liquidity pools, and we can automate the process for every pool, so we can get a profitable arbitrage opportunity.